So question number 9, we need to find the composite of two functions, and then we need to see from that if they're inverses of each other or not. Again, if they are inverses, we'll get x, that the composite equals just x, and if not, we get something else. Okay, so f of g of x, which we have down here. So we're going to take g of x and plug it into f of x. So we take the f of x function, 1 over 3, and then where x is, we put a nice big open parentheses. What goes in here? The whole g of x function, which is 1 over 3 of x. Now we work to simplify. So this really, the outside is 3 over 1, so 3 divided by 3, that's 1, so that cancels. So we have 1 divided by 1 over x. Now when we're dividing by a fraction, remember to divide a fraction, we flip the second fraction and multiply. So 1 divided by, so what we have is, I'll write it up here, 1 divided by 1 over x, the 3's have canceled. Invert and multiply, so that's 1 times x over 1. 1 times x is x. This is equal to x. So yes, they are inverses of each other. So we would check that box, because when we, well, actually, I guess I'm not done yet. I've done it for 1. But you could see g of f of x is going to be the same because we've got the same function. But again, really to do this, you would do g, which is 1 over 3x, and we plug in f of x, which is 1 over 3x. So it's a function that is its own inverse. Again, the 3's cancel. 1 divided by 1 over x, we flip and multiply. This is going to be equal to x as well. So both f of g of x equals x, g of f of x equals x. So yes, they're inverses. Now this one we're going to do in a similar fashion. It's the same function. What we're going to see, I can tell you right now, it's not going to be an inverse because the inverse of addition is subtraction. So anyway, we take f of x, so it's going to be x plus 2. So this is where the input goes. What goes in there? Well, g of x, so whatever this is. X plus 2 plus 2. Take off those parentheses, and then you can combine like terms. That's going to be x plus 4. That's not an inverse. I can tell you that right now, because it doesn't equal x. It's x plus 4. Now the second one, we do the same thing. We start with g of x, which is x plus 2, same thing. Plug in f of x, which is x plus 2. We also get x plus 4, but we didn't end up with just x, so those are not inverses of each other. Let's just go ahead and, I think, continue on to 10, because it's very similar. The one-to-one functions g and h are defined as follows. So we're told that these are one-to-one functions, and then we're asked to find the following: the inverse of g. Now the fact that it is a one-to-one function means it will have an inverse. Okay, or that the inverse will also be a function. So in this case, since we're given g as a collection of points, the inverse is sort of backwards. Now remember, g of x means that x is the input, y is the output. When we have the inverse, what's happening, y is the input, x is the output. So this 7 is a y value. So we're looking which one. There's a y value of 7. What's the x value? -5. Now we're asked to find the inverse of h. Now h is not a collection of points. It's an actual equation. So we look at it as y equals 3x minus 10. To find the inverse, we change the y to x and the x to y. So we're changing their locations, where this really is the inverse function. But to get it in this form where y is the output again, we solve it for y now. So then we add 10 to both sides. And so you get x plus 10 equals 3y. Divide by 3. You get x plus 10 divided by 3. And you can kind of see that instead of multiplying by 3, we're dividing by 3. Instead of subtracting 10, we're adding 10. And we're doing it in the reverse order. We're first adding 10 and then we're dividing by 3, where up here we're multiplying first and then subtracting. So you get opposite operations in the opposite order. That's how we, that's what an inverse does. It does everything backwards. Now this one, we're not going to, you could take this 5, first plug it into this inverse function, get an answer, and then take it and plug it into the original h function, the forward function. What you're going to see is you're going to get 5. Because whenever you plug into an inverse function composite with its original function, remember, this answer, this composite, always has to be equal to x. You start at x, you end at x. You start at 5, you end at 5. So when you see this question, just don't do too much, because you could make a calculation error and you get something else. You start at 5, you gotta end at 5. That's what's going on there. Okay, and let's just go on to 11 while we're here. So we're given a one-to-one function h defined here below, and we've got to do the same thing. Find the inverse function where h is the inverse of h. Also state the domain or range of the inverse function in interval notation. Okay, so to find this inverse, we start off with, instead of h of x, we just use this notation. We use y. We swap the x and the y, so y is now going to be x, x is now going to be y. And now we need to solve for y. Okay, so again, in a sense, this is the inverse function. It just isn't been solved for y, so we don't really have it as this kind of thing. So let's get rid of this fraction. Let's multiply both sides by 8y minus 9. We'll distribute through, so we get 8xy minus 9x on the left side, right? Because we're distribute the x through. The right side, this is the easy part. It cancels, right? This divided by itself is 1, so we just get 3y. Now we need to solve for y, so we have to get everything with a y on the same side. So let's subtract 8xy, because it has a y. We need to get it over, we need to get all the y's on the same side. And you go, well, we got 2 y's, how are we going to get y equals? It's a piece of magic called factoring. So now what we want to do is we've got, emphasize this with a little color, we've got these y's, we can factor them out front. So we divide out the y, we have a 3 left minus 8x. Now you might not see that, but that's that these 2 y's have factored out. Now if you multiply, if you distribute the y back through, you get 3y minus 8xy. You get back to where you started. So this is equivalent. And then we just need to solve for y, so we divide by 3 minus 8x. This is our inverse function. Okay, this side, that cancels. So y equals this. So h inverse of x is negative 9x over 3 minus 8x. Again, we could change the order now. The domain of the inverse, right? Because that's what they ask for. State the domain and range of the inverse function. The domain will be all the x's such that because this is a rational function, we cannot have 0 in the denominator. So it'll be all the x's except the ones where 3 minus 8x ends up being equal to 0. So let's solve this. You could subtract 3 from both sides. So we get negative 8x equals negative 3. Divide by negative 8. So x equals 3/8. That's what we have to exclude from the domain. So everything except 3/8. So 3/8 is excluded. So we're going to go from negative infinity to 3/8, and then we're going to go from 3/8 to positive infinity. It's everything except this number. So negative infinity to 3/8, not including 3/8. That's why we have the parentheses there. Union 3/8. So this is the way of excluding 3/8 with interval notation to infinity. Okay. Now to get the range, you'd have to look on a graph and try to see what are the possible y values, right? Or you just remember that the domain of a function, of an inverse of a function, or the range of, let's see if this, when we get the inverse, the domain and range change places. So here's what we do. So we go back to the original. If we find the domain of this function, that's going to be the range of the inverse function, right? Because we switch the x and the y. So up here the domain would be 8x minus 9 equals 0. This is the one, this is the point we're going to have to remove. So we add 9 to both sides and then divide by 8. We get that x equals 9/8. That's the one point that gets excluded. Again, this is from the domain of the original function, but it will become the range of the inverse function. So we'll say that's 9/8, and then negative infinity to this, and then this to positive infinity. 9/8. That's what we got to do. So come back down here. Our range is going to be negative infinity to 9/8 union 9/8 to positive infinity. So I got that all right. So this would kind of be our answers right here. Box it in. And then while we're at it, let's just go ahead and look at 12. We'll fill in all of these. For each of the graphs below, state whether it is 1-to-1. So a 1-to-1 function passes both the vertical line test. Okay, we got red. So this one, yeah, vertical and the horizontal line test. And you could see, so this is a yes. Vertical line test and horizontal line test. So vertical, yes, yes, that's going to work. Horizontal line test, everywhere it goes, yes, it passes the vertical line test or horizontal line test, so it is 1-to-1. This one, vertical line test, certainly, but not the horizontal line test. See right here, 2 points. This is not 1-to-1. Over here, is this 1-to-1? Vertical line test, yes. Horizontal line test, no. It failed right there. It's not 1-to-1. See, vertical line test, yes. Horizontal line test, let's see, yeah, each one of these, vertical line test, each horizontal line, I get them mixed up, I apologize folks, so that's why I draw them. So this is 1-to-1. And this one also, it's a cubic, is how this is kind of looking, and yes, the vertical line test and horizontal line test, each horizontal line only goes through one place, so that is 1-to-1. Thanks.